Have you ever tried to reproduce some computational experiments from research article? You could get into such a story of relics. Hello Neil, could you please provide the code from your great article? Let's see. Sure, we have written the code long time ago, but you still able to download it from the site of our university. Oh, sorry. My university has blocked my web page since I graduated 3 years ago. So please follow the link to Cloud Drive from my personal blog. I forgot, the space on my drive has been out a year ago, and I've deleted some old stuff to free up my cloud. Unfortunately, you will never more see the code from my article. Why don't you use Docker? Really, why? And even we take more advanced article, we will get into another scenario of portability. Hello Max, could you please provide the code from your great article? Sure, I've uploaded my code on GitHub 5 years ago. Just run cmake and you will get binaries. Forgot to say, you will need Ubuntu 14, but its support ended April 2020, and CUDA 7.5. Why don't you use Docker? And since you've been asked such questions more and more often, you should know that Docker is like FedEx for shipping your code to any infrastructure. What infrastructure could be? Simple and complex. Embedded or mobile. Laptop with Linux, laptop with Windows, desktop, remote desktop, bare metal server, networked servers, virtual machine on bare metal, virtual machine on hosted OS, cluster or HPC cluster, cloud or geo-distributed cloud. We will focus on these types of infrastructure because the way of running Docker containers here is the same. So let's consider infrastructure level. Surely you are familiar with the motherboard, and we can easily identify sockets for CPUs, slots for memory and for GPUs, connectors for HDD or SSD, and for some periphery, I mean input and output like keyboard or screen. But how much connections are underground? A lot. Here is another block diagram of your hardware. You can pause and look more closely. Let's simplify it and make some abstractions. Again, you identify blocks of CPU, memory, disk, GPU, network, and periphery. And to work fine, we need all this stuff that is connected through PCI Express. This is your machine physically. When we focus on certain component of the machine, we name it in a special way. If we are interested in disk of the machine, we name it as storage. When we focus on certain type of periphery, like keyboard or screen, we name the machine a terminal. When we know that machine is available through network remotely, we call it a host. It often happens that you start using laptop as a Swiss Army knife, including for the computations. And you have a lot of succeed of this way because you are familiar with your environment. But one day you join the team. And first of all, you get login and password of Teams server. You decide to connect to remote host. And since this very moment you start using your laptop just as typewriter, namely teletypewriter or TTY, you transfer the source code to the server, connect through SSH to the host, and delegate entire computations to the host, just because it's faster, higher and stronger. Now you don't need CPU, nor a lot of memory, nor GPU at home. You just run your experiments remotely. And collect results. But this stuff will not work at the very first step because of different environments of your machines, local and remote. That includes drivers, daemons, libraries and packages. Moreover, if your code are going to live more than a week and you are not alone who read and write it, then such shuttling is completely wrong way. Because of evolution. All evolves. New members come up and the team evolves. You learn something new, your skills evolves. Following the skills, your code evolves. You install updates on your operating system, new drivers or new packages, or you decide to replace NumPy by, say, JAX, and your environment evolves. What is the problem here? Dependencies. Growth of the team, knowledge and skills reflects on the code. Growth of operating system and infrastructure through updates and upgrades reflects on the environment. What is another problem here? History of the evolution. Without logging, you can't track evolution. You can't come back to your experiment a week ago. To track the content, there is GitHub ecosystem. You will meet it in the next lectures. To track the environment, there is Docker ecosystem, consisting of its own public hub and a tool named Docker Client. Docker Client can control the environment. It can pack the environment. It can tag it to track versions of your application dependencies, publish the package of the environment to the hub, or inherit environment of somebody else from the hub. Docker helps your code to survive in situations when your machine is not the only one where you would like to run your application. When you wrote the code, you can run it on the OS. Sometimes you have to compile it before. After you get your executable file, you can run it, but you can't just move your executable on another machine and assume that it will work, just because executable depends on libraries and sometimes drivers. It would be great to pack, say with tar or zip, all code dependencies and distribute it along with the application. This is what each Windows installer did. And this is exactly what Docker does, but not post factum when you already built your application, but before you start to code, asking you to prepare the file system at the beginning. This is when Docker images are born. Physically, Docker image is a file on a host file system that contains a virtual file system. that is again contains files. This virtual file system consists of file tree branches, named layers. You can overlay of the layers, thereby to add new parts of the environment, vital for growing application. And you can produce your image from Docker file. But Docker file is not a single place where you can get new image from. There is Docker Hub, when you can publish your own images or download foreign images such as JupyterLab or PyTorch with CUDA. And when you run the image, you will get new instance of it named container. Docker container makes your application think it is running on virtual file system, and its lifetime is the shortest and should live while your application is running. Docker container has interfaces to commands, file system, and network, and we will start the seminar by learning these interfaces.